So today we're going to be looking at some geometry, specifically right triangle geometry and the Pythagorean theorem. Pythagoras was a Greek philosopher and mathematician who lived from 570 to 495 BC. Some of the most notable ideas that he has been accredited with are the theory of proportions, the five regular solids, and perhaps most recognizable is the Pythagorean theorem, which is what we're going to be looking at today. The Pythagorean theorem most simply states that in relation to right triangles, a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. Often it's easier to visualize this theorem rather than just talk about the equation. And so what we've got here is a squared in blue, b squared in yellow, and c squared in green. And when you add the yellow and the blue ones together, you're going to get the same area as there is in the green square. Now where the Pythagorean theorem really starts to become useful is when you have two sides of a right triangle and you don't know the third. And so we're going to do a quick example here where we know the two legs of this triangle, but we don't know what the hypotenuse is. And so I've marked them out at 3 and 4 for the legs, and our unknown hypotenuse is x. We can write down the Pythagorean theorem on the right side here as a squared plus b squared equals c squared. We're going to keep them color coordinated, make it a bit easier. So a is going to become 3, b is going to become 4, and c is going to be our x, our unknown variable there. Then 3 squared equals 9, 4 squared is 16, and x squared is going to stay as x squared. We can add our 9 and our 16 together to get 25. So 25 is our x squared, and you can square root both sides of that because the square root of x squared is x, and the square root of 25 is 5. And that's how you use the Pythagorean theorem in order to find your unknown third leg of a triangle. Now it must be stated that that c squared is not always going to be your unknown variable. The c is always going to be the hypotenuse, and it just happened to be our unknown this time because the unknown was the hypotenuse. Let's say instead you knew the hypotenuse and say the 3 on the bottom here. I'll just walk you through this one verbally. Instead of having a squared plus b squared equals c squared, because you know c, in this scenario you would have c squared minus a squared equals b squared. And so then you'd find out that you know 5 squared minus 3 squared equals x squared, which is 25 minus 9. 25 minus 9 is 16, and the square root of 16 is 4. And that's how you do it to find a leg if the leg was the unknown instead of the hypotenuse.